Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Hello there. We are from Group 2 with member Rifky Ahmad Fahrezi, Musyarof Riffai, Hafizh Bani Muazam, and Muhammad Afif Noor. We will present about characteristic of logical gates. Digital system. Digital system. Digital system is an electronic system in which each of its constituent circuit perform discrete signal processing. Digital system consists of several digital or logical circuit, electronic component, and logic gates element for a power or energy transfer purpose. Digital system is a system that functions to measure a fixed or irregular value in the form of a script in the form of digits of number. For example, integers and fraction. Definition: composite of digital electronic component using digital or discrete signal and operates in binary logic plus and minus. 2. Basic logic gates. Logic gates is a circuit with one or more than one input signal but only produce one signal, either high voltage or low voltage. Logic gates are the basic for building digital electronic circuit. A logic gate has one output terminal and one or more input terminal. The outputs and inputs of these logic gates are expressed as high 1 or low 0. In a TTL system, the high level is represented by a voltage of 5 volt, while the low level is represented by a voltage of 0 volt. A digital system that will evaluate the input level and produce a specific output response based on the logic circuit design. There are 7 logic gates, namely AND, OR, inverter, NAND, not AND, not OR, exclusive OR, and exclusive not OR. In this presentation, we will explain 3 basic logic gate type: 1 AND, 2 OR, and 3 NOT. Next will be explained by Rifky.
Thank you, Brother Asaf, for the time given. So far, the first basic logic gate is AND. The AND gate is one of the basic gates that has 2 output channels. An AND gate will produce a binary output depending on the condition of the input and its function. The AND gate has 2 or more than 2 input signals, but only one output signal. Simply, the output signal will be logic high if all inputs are high. And then the notation of AND gate is X equals to A dot B or A and B. And then the symbol of AND gate is like in presentation. And the example of the operation or the truth of table of AND gate is here. If value of A is 0 and B is 0, and then the output or X will be 0. And then if the value of A is 0 and the B is 1, the output will be 0 too. And if the value of A is 1 and B is 0, the value of output is 0 too. And last, if the value of A is 1 and B is 1, the output or the value of X is 1. Next, Brother Ashraf. Then in this section, I will explain of analogy of AND gate. We can analogy of AND gate by the figure in presentation, we can see a circuit that has two switch, this name A and B, and one output is lamp. The output of our Islam will be light up when the two switch are switch closed, uh, like this. So when the okay, then when the switch is closed, will give value 1 and B value 1, then the output is 1 or lamp will be light up. Next, uh, then the example of the IC of that use the function of NKit is IC 7408, like figure out in presentation. So next, uh, Azam will explain about our lucky kids. Thank you.
Okay, thank you for the time, Mas Rifki. I will be explain about OR gates. The OR gates is one of the basic logic gates that has two or more input-output channels and an output channel. And an OR gate will produce a logic 1 output if one or all of its input lines get a logic value of 1. The OR gate has the property that if one of the input signal is high, the output signal will be high as well. Simply, OR gates is the output signal will be logic high if any or all of the input signal are high. Okay, and OR gate notation can be with A or B. And the right side is OR gate symbol, and the below is truth table of OR gate. The example, if value A is 0 and value B is 0, so value X is 0. If value is 0 and value B is 1, so value X is 1. And then if value A is 1 and value B is 0, so value X is 1. And the last, if value A is 1 and value B is 1, so value X is 1. Next slide. Next slide, Mas Asrof. Okay, the next slide I will be explain about OR gate analogy. OR gate analogy is the two input OR gate can be analogous to two parallel switches to turn on a lamp. As shown in the figure of presentation, where the lamp will light up when either the SA switch or the SB switch is closed. Next. Next, Asrof. Okay, next. This is one of the example by OR gates. This is IC 7432. Okay, next will be explained by Afif.
The last one is NOT gate. The NOT gate is also known as the inverter gate. This gate the most easily remembered logic gate. A NOT gate will always return a logical value that is contrary to a logical condition on its input line. Example in table, if the input channel gets a logic value of 0, then the output channel will produce a logic value of 1. And if the input channel gets a logic value of 1, then the output channel will produce a logic value of 0. Next slide. NOT gate analogy. The NOT gate can be analogous to a switch that is connected to a normally closed relay to turn on the light, as shown in figure, where if the SA switch is open, logic 0, then the relay S is closed, so the light is on, logic 1. Whereas when the switch is open, logic 0, then the relay is open condition, so the light goes out, logic 0. Next slide. NOT gate using IC 7404. The NOT gate has one input line and one output line. NOT gate circuit constructed using a transistor and two resistors. Next slide. Summary of presentation. For AND gate, the output signal will be logic high if all inputs are high. For OR gate, the output signal will be logic high if any or all of the input signal are high. For NOT gate, the output signal is inversely proportional to the input signal. Next. Okay, that's it from us. More or less, we apologize. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.